welcome. Today we're going to talk about series. So when we talk about series in AP Calculus, remember those 10 formula will help you solve 17% of the series problem. Later on, you will use those kind of series, for example, like the ratio test to find the range of conversion, and then if you later on need to solve some kind of like monomer or Taylor polymerase series or some power series, it will just be more in depth. But today we're going to focus on the ratio test. So those are just tests to prove convergence and divergence of the series. And maybe sometime you will have to find the sum if you encounter geometry series, or maybe you need to find some remainder. You can also find remainder with Morrow and Taylor series, but like again, that's stuff for later. So for ratio tests, this sign represents odd number in the middle plus together. Normally it will start with some sort of n, and then you have some sort of equation that you can plug the n into it, and then you need to plus them all together. I think when you come to this video, you probably already know of those from your pre-calculus class. And then ratio tests say that an to be a series of non-zero term, and then we notice that an will converge absolutely from last picture, and then it will diverge when it's bigger than 0 or equal to infinity, or give you something called non-exist. And the ratio tests have its limitation. It will be inconclusive if this equation was neither bigger than 1 or smaller than 1, which means it will be inconclusive when it was equal to 1. So let me show you the proof of these things. So to prove that the property 1, which we just say that limit of n equal to infinity, an plus 1 over an, the absolute value of that was smaller than 1. So let's assume that limit as n approach to infinity, an plus 1 over an was equal to a constant r, and this r was smaller than 1. So we will choose another value called big R, and for big R, that the r smaller than big R will be smaller than 1. By definition of the limit of a sequence, there exists some kind of n that was bigger than 0, such that absolute value of an plus 1 over an, because it's equal to r, it will be smaller than big R. For all n bigger than big N. Up to this step, no problem, right? Therefore, we can write the following inequality by those definitions. No problem, right? Now I plug in big N for small n, because I stated in front that we assume there was some kind of number n bigger than 0. And this will be smaller than an r squared. Easy to see why, right? Because from the first equation it was equal to r, and r was smaller than big R, so we times another big R. This will definitely be bigger than the things in front. So by the statement we stated before, we have a r. The r was bigger than r smaller than 1, and it was always bigger than 0. By the definition of the limit of the sequence, we state that there will be a n bigger than 0 such that an plus 1 over an was smaller than r, and n was always bigger than the big N. And we can write those inequality. When we have those inequality, we can come out with a geometry series, which is that, and we know this will be converged. Consider that when we're stating it, it was smaller than 1. Anyway, so by direct comparison test, this series will also converge. Implies that the series a small n also converge, and this is because that there was finite number of terms that will not affect the convergence. Consequently, the series an converge absolutely, and the proof for property 2 was similar to property 1. Okay, but after I talk about so much proof, you don't need to know those proof for your AP exam. All you need to know for your AP exam is memorize this equation that limit n approach to infinity, and set your an plus 1 over an and see if it's smaller than 1. If it is, to answer any FRQ related to this, you said by the ratio test, this series converge absolutely. If it was bigger than 1, all you need to write was this series diverge. Done. Okay, let's look at some example problem to make this more interesting. But before we start the example problem, let's talk about some strategies when you are approaching a series problem. So first, use the nth term test because it's the most simple test. And if it was like approach to 0, then you need to think about other tests. If it's not, the series diverge. So easy. Okay, then if you cannot tell directly from the series of like which test to use, after you do a lot of problem, you will get a sense of which test to use. But if the question do not tell you and you don't have that idea, the next things you should look at is geometry, P series, Taylor score, or alternating. Those are some special type of series you can tell by a glance. And the general equation I have shown you in the beginning of the video. If all those tests do not work, then try integral test, root test, or ratio test. If it still do not work, then can the series be compared favorably to one of the special type, and try to alternate yourself. Okay. Do you see this exclamation mark? Normally when you see a question that have an exclamation mark, you should probably use the ratio test. Why? Because exclamation mark is really hard to calculate with other tests, and if you use the ratio test, normally the exclamation mark will be cancelled off. It will be have something like n plus 1 or n minus 1, which will make your life easier. So when we are looking at the question sheet from the beginning, what we see for ratio test, the general equation was that n and infinity on top, right? So what should we do right now? N equal to 0. So we need to try to convert n equal to 1. There are two ways you can do it. Because we know this is meaning the sum of some kind of n1 plus n2 when you plug it in, starting from n equal to 0, keep plusing, right? If you put in n equal to 0, exclamation part of 0 is just 1, 3 to the 0 is just 1, you know it's just 1. So what you have will be, boom, done. The n now equal to 1. Match this equation. If this converge plussing a constant, most of the cases it will still converge. But if you want to be more, what's the word we are talking about? N equal to 1. All you could do was minus each things by each n in the equation by 1. When you plug in n equal to 1, you're still starting at 0. No problem. Okay. Let's use this one. This one looks cool. So what's we supposed to do? Well, we're supposed to do something called an plus 1, right? So for this case, an plus 1. So when you are dividing something, it's equal to multiply its reciprocal. Okay, this is where the fun begins. Why we need to know about this exclamation mark? Because what's an exclamation mark mean? Well, 3 exclamation mark means 3 times 2 times 1. So n exclamation mark could just be n times n minus 1, keep continue. So n times 1 minus 1 exclamation mark. We can easily make this equation into, we do realize that, say 3, 2 divided 3, 1 will just be 3. 3, 3 divided by 3, 2 will just be 3. So here we can see on the bottom it will just be 3. And then those 2 can just cancel off. So therefore, 3n can be separated into 3 times 3n minus 1. So left behind is 3, and on top is just n. And as n approach to infinity, divide a constant, it will just be infinity. Therefore, this is divergent. So let's find a question that was converged. So another easy pattern to see, if you have some kind of 4n at the bottom and the top is not power, ratio test will be the first things to come into mind. Why? Well, first, like last time, n plus 1 and n minus 1 can easily make it a power into a constant, and if the top and bottom don't have the same, same power, you don't need to use the root test. Just some pattern when you start seeing, when you do a lot of questions. So again, n plus 1 over 4n plus 1, n approach to infinity, n plus 1 over 4n plus 1, and then times 4 over, those 2 will just give you a constant. When you start doing more questions, you automatically know when you select those source things, it will just give you the base as a constant. So that will give me, right? And when n approach to infinity, and the first one, see, the power are same as our 1. We know that this will ultimately give you, is there any coefficient? No, so 1. And it will be 1 over 4. And we all know 1 over 4 is smaller than 1, right? This is absolutely converged. Thank you very much.